G'day guys, going to do a bit of a talk about bigger than normal coils. Well, it also applies to small coils, but as you can see, this one, if you can read that, this is one of the, what I would classify as one of the best coils that minelab ever put out. It is a Kevlar coil, as far as I remember. I'm pretty sure it is. I mean, this is an old coil. Yes, this is the Kevlar version. Let's pull it apart, or part thereof apart. It's been sitting up in the cupboard for a while, but this is one of the best coil. Well, it was a really good coil, but I did some modifications to this coil that made it even better. So it's an 18-inch, so it's pretty big, and you can see that's a skid plate for it, which has had a bit of a scuffing, but it's these Kevlar. I'm pretty sure, I'm not sure, hang on. Am I sure or am I not sure? I don't know if the skid plate is ABS. No, it feels like fiberglass. But let's have hang on, just let me have a look at this. It's got a lot of marks on it, but it's very shiny. It's not ABS, it is that Kevlar, it's a Kevlar coil for sure. Okay, but I'm going to show you some interesting things about these big coils and how you can make them go really, really well on these newer PI detectors that are very fast, and they've got fast modes. What I've noticed, and I'll tell you this right now, some of the, say a GPX 5000, if you're using enhanced mode and you've got everything turned up, it's got some very short, sharp, narrow pulses. And what happens? If the coil has a lot of intrinsic capacitance, basically in the shield to the windings or interwinding, whatever, it desensitizes. You've got to be careful with your choice of coil. And when you have a look at, say, the 4500 detector, which did not have that fine gold mode. I hope I said fine gold before. I didn't say enhanced, did I? I was mucking around with enhanced before anyway, so on a detector. But fine gold, if I said enhanced, I do mean fine gold. It's got very short, sharp pulses and very, very, very close in receive windows off those pulses. And if the whole thing doesn't dampen out properly in the right time period, the receiver comes on, gets a blast of the decay curve coming in, or even the ground response, and she desensitizes and it goes deaf. And you think your detector's working beautiful and quiet, and you're not getting anywhere. Be careful with enhanced mode on some coils, in my opinion. But anyway, this thing here, when these came out, they're a very thin coil. I'll just put this down. Well, actually, yeah, I'll do that. I'll just put that down a bit so you can see what I'm playing with. The cable on these too, that's very old cable, but it's very soft and pliable. It's like a rubber, a butyl rubber or something. I don't know exactly, but stays soft. And it hasn't deteriorated, even though this is a very old coil. And this is a coil I used in Creswick to find a lot of deep gold many, many years ago, back in the probably would have been late 90s, somewhere around there. But anyway, this is this coil. Now, what I've done, you have a look at it, you probably notice it's very thick. And there's a reason why I made it thick. And it's going to be very awkward to handle. There's going to be a lot of interesting things about this. First of all, let's get on the bottom of the coil and have a look. And you can see in a previous video, I said about the 4-quadrant shielding, and to keep it grounded or connected, get some continuity across it. What I've done, I've actually cut some grooves across and across. There's actually the material's been removed. This whole thing was painted black to start with conductive paint, and then I've gouged it out. And what I've done then is I have put some tape across where it was gouged out, and it's actually painted on one side and not the other. So it's like a lip. It's like, it's going to fall on the ground if I do that, but it's like this. This is painted to the rest of it. Here it goes on top of the painted base, but this bit here is not connected. It floats, so it's like a bit of a capacitor. Well, it looks like it, but it's not really, because it's actually all connected. But anyway, I'm breaking up the shielding, but it's still shielded. It's just layered like so. So it's not one big piece of shielding. It's 4 little sections of shielding. But if you get my gist of how it's done, it's just masking tape painted black. One side's like dabbed on here. It's very conductive. It's conductive across the tape, but this part of the tape, this side, is not connected to that electrically. It's just over it. So it's just covering the trench, basically. A little bit of a removal of material. The other thing about this coil as well, as you probably notice, it's very thick. This is probably twice as thick this way as what a normal coil that was in here. And I also said before, don't use the blue foam, but I did. I did this years and years ago, but I used the blue foam because this is what happens if you scratch it. You know, it will gouge very easy. Where the honeycomb type material, what they use for making surfboards, doesn't. So that's this coil. But I'm going to show you some interesting things about this. Even on this side here, you can see it's got a couple of scratches and gouges. If those gouges and scratches were anywhere near the windings here, right, as you went over the ground and it went over anything that upset the apple cart, green shrubbery, or even just the ground in general, it will cause a capacitive effect on the windings. This is no longer protecting it because the paint or shielding has come off. Even a small bit like that right in the winding, it will cause a very big effect. You'll have a noisy coil. So, what I do is I just touch that over and so forth, so it's no big deal. The other thing too, I've offset the windings. And the reason, I'll go into some detail on this because I probably have to. The windings are in here. They are a special winding I did, which I came up with a while ago. And they're in there. They're nice and tight. They're not glued in as such, but I've done a bit of a chemical treatment inside here, which keeps it as basically near an air-gapped solid lump, right? It's hard to explain, and because it's a bit sensitive, I'm not going to go and mention it. But the other thing I've done too, when I put the groove in here to put the windings, you can probably see as an offset, it's thinner here and thicker here. That is to get the windings closer to the ground, but I've also kept the shielding away from the windings on the top part, because who cares about the top part of the coil, unless you're detecting upside down, which is not normal. But the higher this is, the less capacitance there is from this shielding to the windings. And if you have the whole thing very, very skinny, you're going to get a lot of capacitance between the actual windings and the shield. So you'll have a high capacitance between the winding and the shield, and the least capacitance is the better overall if you want a fast coil. And air gapping, spacing, I think I've gone over a lot in other videos about making a really good coil. But that is an absolute ripper of a coil. And if I remember, I've got my multimeter here. I was going to just test this on continuity, because I did a lot of testing in the early days trying to get the shielding to a point where it wasn't like, 1 ohm or something like that. It wasn't basically, a near enough a dead short circuit across the whole thing, because that just kills the functionality of the coil. It goes deaf. You'll lose a lot of signal. So on this, nearly dropped it again. It's very awkward. And because I've made a big fat thing, it doesn't actually go together properly. It has a gap, and I just went around that with masking tape, and I put some clear seal on it. So you could use a waterproof tape. You could use electrical tape, but it slides off when it gets hot. So I did use I think I use a cloth tape, and I put some clear seal on it. But I pulled this apart, and it's no longer there. It's just common sense. So I've got the meter here. I don't know if you can see it. So we'll go over this roughly an inch apart, and basically 700 ohms. Now, the reason it's 700 odd ohms, it's a little bit higher than what some of the other coils are. But the reason is that the way I've got it set up and the spacings, there is enough shielding there that it does not give any ground effect or any effect to any green vegetation or anything that normally sounds off on a coil. So that might be something worth remembering. This is done, Jesus, you know, three decades ago type thing. But yeah, if I get a bit closer, it's going to read more. But I'm pushing hard like hell, so we're down to 300 ohms. But on the other side of the coil here, we're under 1,000 ohms. But that was the design of the coil. Normally these things 120 or 80 ohms. They vary. Depends who made the coil on the day. And this was done using Y Shield, which is I'm pretty sure it's a German company that makes this. This stuff's expensive. It probably has come down. But that HS54, if you put that on a coil, this one, it will not work. It's too low in resistance. If you paint this on straight, it'll have a resistance of about, well, under 10 ohms. It'll probably be something like 2 ohms, which will just short the whole coil out. So you're shorting out a transformer. So you don't use that. You can't use that as well. This is the NFF34. And the trick to getting the right resistance using these, because it's actually in bulk, it's probably the cheapest way to go if you're going to make a lot of coils. You can get this in 5 litre and 20 litre drums. It'd probably cost you an arm and a leg, but it's probably, if you're going to make a lot of coils, it'd be very cost effective. So what you do with this paint on shielding is, first of all, you get it, you shake the living hell out of it, right? Shake it for a good, I don't know, 3, 4, 5 minutes, whatever. Basically, something along the lines of shake it like crazy, and wipe it off the threads on the lid when you use it, because what actually happens is it gets in there, and when it dries, it's nearly impossible to get the lid off. So be aware of that. I've had it before. I put big vice grips on here trying to get the lid off, and it nearly chews the plastic off. It is bound on so hard. And if it does do that, what I do, make sure the lid is on tight, put it in hot water upside down just to heat it all up, get a flat blade screwdriver, work it around the lid a little bit, move it a couple of millimeters, 1/32 of an inch if you're that way inclined, and break the seal, and then twist it off, and then get a screwdriver and break all the hard dried stuff off. So don't let that stuff set in the actual lids. It will be not very good. So anyway, this coil here will work on anything. It is super fast, extremely low capacitance. It had a self-resonant frequency well over, I'll try to remember this, but I'm pretty sure it was around about 580 kilohertz or something, which is quite fast for such a big coil. And very low capacitance too between shield and winding. That's the way I had it configured. But that's it. All here It's just masking tape. I just went around with masking tape and I've painted it, and it's actually very solid. It's a quick coil for the day, and it worked really, really well. So that's that coil there. That's a Kevlar one. We believe it's Kevlar. I'm pretty sure it is. It doesn't look like ABS, even though that's textured. I don't know. Everyone I know, even professional prospectors, have called these a Kevlar coil. The one before this, the big one, was the dustbin. Well, that looks like a dustbin lid too. But the other one looked like we called that the dustbin lid, and that was heavy fiberglass. And that was a bit of a clunker of a coil. Still worked, but yeah, that's that. Now, the other thing about making coils, rather than getting the foam and painting the foam, it's it's a lot of paint goes on there, and if you want to pull it apart and pull the windings out and stuff, you got to repaint it. What I've done, and this is one of Nugget Finder's little coils. I've had this kicking around. I've got the bit over there, and what I did on this one, and if you can see, I've got to show it in some detail because it's very easy to stuff up the shielding if you don't do it right. That Y shield paint, um, that's a bit of white paper there. It hasn't come off. But when you paint ABS, it absolutely sticks like you know what to a blanket. It won't come off. And what you got to do with this, it's quite some little tricks of the trade. You can have this completely painted, not a problem. And you paint the lip here. So the lip there is all painted all the way around. And I think on this one, I might have left a little bit of a gap right there. There's a little bit of a gap. I don't know if you can see that, but there's a gap there. There's no paint on it because this around the winding, if it's low enough in resistance, will act like a winding itself. It will couple with the detector coil metal winding or copper winding, Litz wire winding, whatever, and it will short it. It tries to short it out. You know how transformers work, I hope. You have a coil of wire, possibly a core, either laminated iron core if you're doing low frequency stuff, ferrite core for higher frequency stuff, or if you're doing RF, it's probably air core. But this stuff is low frequency, but we can't use iron core anything. It'll just kill the performance of the coil. It won't work. It'll be like you put a big lump of iron on top and you got a monkey on your back. So you don't want that. So what I've done with this, and this is just so I can make up lots and lots of little inserts of different type of coils. I don't have to paint the foam. It goes in here. Now, there's a trick to this, and this is important. You cannot just put the foam in there and just sandwich it together and put your braid on the outside of the cable to this and say, she'll be right, it'll touch. Can't do that. It'll be noisy. The slightest thermal movement of this out in the sun will cause this inner lip here to rub on the other piece that goes inside. So it'll just move very slightly. And these are so sensitive, it'll pick it up. But there's a trick to this. There is a trick. This is mainly for experimenters. If you want to experiment with coils, this is the way to do it. What you do, this here is fiberglass bandage. Okay, they use this for plaster repair, for running down two pieces of plaster, and you're actually meant to put on cement, some filler, and push it in. But this stuff is really, really good and bonds very, very well with the Y shield or any of these carbon-based paints, even the guitar cavity shield paint. So what you do, you get something like this type of wire here, and I haven't got my cutters. Where are they? Anyway, what you want to do, this stuff is probably about 16 strands of tin plated wire. And what you want to do is just strip off the insulation so you have a strand, maybe a couple of strands, make it so long, like thus. And say we look at Nugget Finder's coil, because I've modified this, haven't I? I was going to show you. But I don't have a look at this. I've done very fine wires, but I fanned them out. I don't know if you can actually see it. Can you see the fanned wires here? You don't need all these wires. This was just a small coil, and the overall conductivity and capacitance didn't have much of an effect because it's a small surface area. So there's probably the original wire right here. Okay, it's on this side, but there's a way of doing this with the fine wire. I'll try and get this up and I'll show you. I'll do it this way. You might be able to see against that white paper that's stuck there. I don't know if you can see it. It's a very, well, I'm grabbing the end of it there. It's a very fine wire. See, that's like hair wire. That is tin plated copper. Don't use copper, use tin plated copper. Even though at that fine diameter, which is, probably 0.12 millimeter or somewhere around about that, it probably won't make much difference, but it's better to get tin plated wire. Copper does oxidize, and also copper doesn't burn off the well, you're not going to get cross-sectional eddy currents on that at the frequencies these detectors operate at. But the thing is, it's probably a good idea to use tin-plated wire so it doesn't oxidize and stop making a connection with this black stuff. But what I do, I get a strand of wire, probably, I don't know, that long. You can use that long, whatever. And I'll show you on this bit of foam here what you do. When your wire goes in and your braid is here, this little wire, you solder the wire to the braid, okay? And what has been done here, it's been dabbed with the paint with some, like blobs. It dries flat, but it will hold the wire perfectly. And there's a tiny little punch hole here. I'm pretty sure there's a little hole here. There could be, or could even be that hole there. It doesn't make much difference where you do it, but you run your wire out. And on this one, there is actually, I don't know if this is the factory one or I've done this. There's a hole here, and the other end of the wire comes out here and sticks on this. So it's basically a little wire is connected to this, and if you have your windings in here, whatever you can use masking tape, as long as you don't crush it in and it becomes, like a concertina. Make this hard. Like this one had silicon in it, so it would have been a hard, uh, you know, sort of construction technique. But you can just use wide masking tape, put it around, paint it with the conductive stuff. A trick is too, when you paint this here, you probably want to adjust your resistance to be a little bit higher. You can go to about 1,000 ohms in the resistance here. You can go low on here, but as I say, it's a small coil. You can probably just do the whole thing at around 100 ohms. If you measure it like that, 100 ohms, 180, 1,000, doesn't make much difference. Just depends on how close the wires get to the ground. The greater the resistance of this, the closer the wires, the more the ground interaction. It sort of just leaks through. You really got to create a Faraday shield, and there's a limit to how much resistance you can have either way. One way shorts out the functionality of the coil. The other way, it becomes so high in resistance that you're going to get bleed through from the ground, acting the capacitance of the ground to the coil, interacting with the coil windings, and as you go to the ground, it's going to go woo, 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 and won't ground balance. So you've got to be, it's like you've got to test it, I do have all this in my book somewhere, but a long time ago. Uh, I just do it by feel these days. I go, oh, that's about right. That's about right. It usually works. So on this, rather than painting that if you don't want to, you can paint this. What you do with the wire, where I've got that bandage, put the wire on, put some paint on the wire. You know, it doesn't matter where it goes. It can go there, it can go there, there, whatever. Doesn't make any difference. And then when it's set down, you put the bandage over part of the wire. So the wire's under the bandage and then comes out. And you put some more paint on, some more of that wire shield, which you mix the two together to get your resistance. I'll go into that in a minute anyway. And have your little tiny thin wire that's not going to interact with anything except the shield. It keeps the shield good. And what you do then, you have it come up through your foam. Just keep it long so you can bring it up, have a little hole through your foam, and then you can lay it on the other side, and you can have on the top part of the coil, you can actually have a bit of bandage like this thing. You can just lay the wire on that bandage, and because on the top part of the coil, that's the bottom part, but anyway, on the top part, um, just usually just having this paint in compression, uh, it works fine because it's not interacting with the ground. If if it came loose and that and you put your hand on the coil, maybe it would, but I've never had that problem. So you can do a hard fixture on the bottom of the coil, and you can just have, a bit of a iffy type connection on top. Better still would be when you put the coil together, you'd just put the wire on top of the foam where it's meant to be, dab some paint on it, have this bandage because it adheres really well, and then just sandwich the whole thing together, and it'd probably be perfect. Well, it would be perfect. It's not going to do anything, but there's many ways of doing it. The main thing is, and I found this when I said about this inner lip here, you want it overlapping. And where is that bit? Over here. Oh, there we go. You want it painted on the inside there as such, right? So it's all painted on the lip of that, but it's a very small lip. You can see it's a very small lip, right? And you want this to go in here as such. And it has that much coverage. So the thin lip gives you that much coverage. And what you don't want to happen when you're using the fine wire technique is you do not want to get the carbon on this lip here, on the big part, up here, and it goes on here because it's going to connect to the carbon on the top. You want to have it back. This one, I probably should have done it myself, but like I say, you want to have something like, a 32nd of an inch or a millimeter and a half or two, not critical, that the paint is not there. It's not round there, so it can't force its way onto that. And you want the carbon here. You can paint the outside here on the lip. There's no way known they can touch because it's on the outside. So, it would give a better shielding effect. So that is how you do these coils. If you want to paint it like that, it's fine. You're just going to make sure that the coil on the inside does not flex around because it'll change capacitance on the bottom and possibly even on the top plate to a degree. But on that, it's spaced away. It doesn't make any difference. But I didn't do this technique on that big coil down there. So you can wind up stuff and you can try different windings and then put it back in your sandwich. Try it, see how it goes. Pull. Don't have to really have it glued together. Just put a couple of rubber bands around it, keep it together, and then you got another little bit you want to put inside it. Just leave your wire tail, the fine one for the grounding. Hang it loose. Just pull it off the top bit off this gauze or whatever you put in there, and yeah, you can pull it apart and do what you want. Do lots of experiments rather than wasting you're shielding paint on lots and lots of cores. So you can just leave the cores free. You know, obviously that one's painted, but it doesn't have to be. So there's just options, because of what I've done over the years. I know what works, so it would work. The other thing too, now I was going through my old pictures actually looking for some information on my old coils, right? But I did find this interesting thing, and I forgot it's years old, and I forgot I even had it, but it's quite interesting, right? This is a fellow. He lives in New Zealand. His name's Bevan. Uh, I haven't heard from him for years and years. But this is when the 4500 first came out. And I'll show you here. This is his picture. So, Bevan, if you see this, you can verify it. Come on, wake up. There it is. I don't know if you can actually see that. I'll move this camera. So, excuse the bumps and wiggles and clunks and things as I do this, because it will. If you have a look at that there, we go. This is no joke. This is fair income, 100%. This is the photo he sent me from New Zealand. This was 4 operators of GPX 4500s back when they first came out. And this is what the 4 operators combined got gold-wise on the trip. That's what they got. That's it. That's a total. 4 men got that. Now, Bevan was using a modified SD2200D, which is a fairly old detector. And, I did some upgrades to that detector. And this is Bevan's gold. This is Bevan's gold with that modified SD2200. To me, Eva Bevan is a very, very, very good operator. These 4 guys had no clue to what they were doing, or the modified SD2200 outperformed the 4 operators. I think the picture, if I remember rightly, like I say, this is a long time ago, this might have been one operator of a 45. This might have been another operator of a 45. This was another operator, and that was another. So it's 1, 2, 3, 4. But the modified 2200, if you have a look here, it was getting small stuff, but it was getting these bigger bits at depth. You're going to say too that this guy got a bigger bit at depth. I'd say that's I'm not 100% sure, but I'm trying to recall this from a long time ago. And you got to remember, I've seen hundreds of people's pictures of gold over the years. We get a lot sent in, but some of them don't mind it being put out there, and some do. So it's sort of like for your eyes only type. But this is, I think this was a free to air version for memory. I hope I'm right. So Bevan, you can chew my ear off if I got it wrong, but I'm pretty sure. And you could probably, if you're still out there, you can probably fill us in if that was one operator, that was the second, that was the third, and that was the fourth, and that was the 2200 that was modified. So, like I say, I don't know the ground conditions in New Zealand. I've never gone over there, don't know, but that's the end result. So, yeah, I just thought that was a interesting throwback to the past, to these earlier detectors definitely go deep, and they go deep on big gold, as far as I could tell from these pictures, because whoever that is, they didn't get any big gold, and they really didn't. Yeah, so that's that. But anyway, the next thing I'm going to, yeah, I thought it had his name on it. Maybe I have to click it. Yeah, Bevan's Gold.jpg. So anyway, that's Bevan's. Okay, I'll move this back, or else it's all going to get crowded and horrible. Just noticed the tripod's on a bit of an angle, bad luck. Okay, so we got this stuff here, this NS HSF34 and we got the HSF54. So you really want both of these, because what I do, I get a little, I'll tell you what I get. I get something, this is something I made up with graphite in it and all settled, but anyway, one of these things with measures on it. I get maybe 1 mil or 2 mil of one, and I'll put in with another one of these, squirty bottle things that this sucks up. Just half the amount. I put in, say, the 54 with the really low resistance, and I'll get this NSF34. And what I'll actually do, I'll put in, say, roughly work it out. So you got, say, 5%, 10%, or whatever. I'll spin that around a bit more. Put the into I put into a little shot glass actually, and I put it in. And then what I do, I put in so much, and I write it down. I mix it up quite well. Use a cotton bud to mix it up because it makes a good paintbrush. And what I do, Q-tip, I think you call them, if you want to be technical about it, and get some masking tape, put it down, and just wipe it on the masking tape. Then put a bit more of this in, write it down, mix it up again, put it on the masking tape, keep it all documented, and let it dry. And when it dries, you'll know how much of what to put in what to get the right resistance that you're after. So anywhere, but look, really anything probably between 50 ohms per inch, probably up to 1,000 ohms if you don't have your coil windings too close to the ground, and you do that spacing technique I did as well, you can make a very, very good coil. And make sure you use a thin tin-plated wire. Don't use big bundy wire. You say, oh, that'll be better because it won't break. It'll break your coil. It'll act as a piece of metal in the coil. It just does. Trust me, you got to use very, very thin wire. And yeah, that's how you make really good coils. But that one there needs a bit of touch-up work on it, and we'll go out and I've got some detectors I've done, which are super sensitive, by the way, and I want to actually put this coil back together and try it and clock these detectors a lot faster than what I've been doing. I've changed the damping in the detectors as well. I thought about putting switch resistor damping in the detector, so if I'm using longer pulses, you can use the existing 300 and whatever it is, 390 ohm resistor. Or what I thought about doing, I could put in another small MOSFET and just switch another resistor in and out. You could run the wires to actually a switch, but you'll have interaction between the wires of the switch and the damping circuit, and it's gonna return signal on it, and it's gonna have all sorts of things you don't really want, like flyback pulses riding that as well. And I'd say just copy the existing small MOSFET on a subboard and put a switch in there, so you can even switch. If you want to get really technical, you can switch one in, both in, one out, and you can have a combination. You can do that. It's a good way of doing damping like that. I used to use a padded potentiometer of around about 3 watts, carbon. Don't use a wire wound one. You're going to cause lightning. You'll blow your detector up. Use a carbon pot. It's got to be enough wattage rated so it doesn't just burn out. But I always put a paddle resistor across it, so you give it a fixed value of, say, 500 ohms or 600 ohms, whatever it may be, and the resistor, you can adjust it, but don't adjust it all the way down to 0 because it'll blow the bloody detector up. So you need a series resistor of a given amount, safe amount, maybe 150 ohms. So you can go between, say, 150 to 550 ohms padded, because the padding resistor takes the brunt of the damping current, so it doesn't burn out. You don't want your pot burning out if you're just relying on a potentiometer. It will burn through and you'll have no damping, and then you'll blow your front end out of your detector. So you've got to be careful doing this stuff. But that's a good way of doing it. And then you can experiment around with all sorts of different windings. You can reduce your pulse lengths and run, faster and all the rest of it, and match the damping to that. You could also then crank the frequency down your detector. You can get away from winding more windings on these coils. Uh, I haven't done it on the more modern detectors. From basically, I haven't even done it on GPX Extreme, but I've done it on the SDs, and especially I'd done this on a SD2000. I cranked it right back. And I was running very, very long pulses. I had to beef up the transmitter stage, replace the diodes, series diodes, and um, I think I might have done a little bit of work on the damping circuit there with the adjustable pot. And I was actually running that detector at 600 microhenries on the coil inductance, which, because it squares, it's not that many more turns, but it's a lot of inductance. And getting the extra turns in there, it gives you a better receive pickup from bigger targets deep, especially at long pulses. The more turns, the more antenna. Basically, the bigger your antenna, the more signal you're going to receive. So, bye bye. Yeah. Um, yeah, that's probably about it on this one. And guys, you might have noticed what my previous video has disappeared. Uh, yeah. Um, it has to. It has to. It just had to disappear. And what I wanted to do is replace that video with this, a big smiley face, and leave it there. But I can't go into it. It's I'm trying to think of the right words to say, because I'd say the slightest wrong thing would give the wrong connotation. But yeah, yeah, something along the lines of I don't want to give too much away. Leave it at that. Yeah, because when you put videos like that out, there was feedback, right? And some of the feedback, we didn't like the sound of it. But I'm not going to go into that. I really aren't, because you can make up your own mind on that. Might have ruffled some feathers or something. I don't know. But that's that. Anyway, hope you learnt something from that lot. I'm getting tongue tied talking too much. So big coils, if you follow the techniques I did on that big coil there, that 18, even bigger, you can make really, really good coils. And, you can turn it into a multi-purpose coil too, because by staggering the spacing of the shielding, you're lowering your capacitance between the whole shield and the winding. You can run it in faster modes and things. Every little change you do reacts differently with gold that's buried. Some little change you do this, and you go, well, that signal wasn't there before, now it is. So yeah, that's for all you experimenters. I know there's a lot of guys experimenting, and I keep getting asked questions about it. And can you explain this better? Sometimes it's when you know something yourself, it's very hard to explain it. It's like listening to your accountant, and you go, he knows what he's talking about, and you're going, huh? What? Same sort of thing. I know what I'm doing, and sometimes it's very, very hard to convey it, and also to keep it simple. Uh, you know, some people, might say, "What's inductance? What does that mean?" Um, that's the amount of coil windings there are, and if you put more and more on, the inductance goes up, and it has to meet criteria of the detector to work efficiently. You don't want to massively, you don't want, um, I was going to say a millihenry. Someone's going to say, what's a millihenry? But you don't want a huge amount of windings that you can't energize and it's just there. Um, you know, it, was going to say something then, but I'm not going to now. Yeah, just well, more windings, more receive, but it's not good for the transmitter. Okay, you can't dump the energy in quick enough unless you lower the pulses down. But yeah, two windings. Anyone say two windings? But there, you can't do. Yes, you can. Yes, you can. It's a double D done as a coplanar, of course. But that, so I said coplanar. What's that? That's a winding like this and a winding like that, and you use a big one, say possibly for your transmit, and use a small one. Put lots and lots of turns on it and a damping resistor on that coil, and use that for your receive. Or you can stagger another one out, but don't put them in series. Whatever you do with resistors across them, because that's patented. What they call that cross field, no, dual field coil, where it's driven off one single transmitter. And that just, I'm going to stop there because I'm saying too much. Anyway, catch us later.